Okay, so again, if you look at the verification activities for the outputs of the software coding and integration process. So integration, remember, we try to integrate the whole module, compile it, link it, and put it on the target. And again, the source code needs to comply with the low-level requirements and with the software architecture. And of course, needs to be traceable to the low-level requirements. I mean, like the high-level and low-level requirements, there are some other items here. We'll talk about that, about these objectives when we start talking about the verification activities in modules 8 and 9. So again, so now one thing to realize is that we said earlier on that in the planning phase that it's important to define requirement standards, design standards, and coding standards. The latter, the coding standard, is important for the source code. Yeah. So one example of that, so that it also has a dedicated objective associated with it. Well, one example is the MISRA-C standard, and if you look at it, this one was released in 2004, titled Guidelines for the Use of the C language in Critical Systems. So it's really meant for, okay, I'm going to use C for a software that I'm going to do in an embedded processor for a safety critical system. Then MISRA-C is one of the coding standards that you could use. This coding standard includes 141 rules, of which 121 are mandatory and 20 are advisory. And all these rules apply to the source code, not to the object code. And what you see is that a lot of commercial products out there, like for example Simulink, Stateflow, and Embedded Coder from the MathWorks that make MATLAB, are widely used to generate embedded software, and they follow this coding standard. Also, the polyspace tool verifies that you adhere to the MISRA-C coding standard. Now, a couple of things, of course. One thing that in the MISRA-C coding standard, they come up with a set of definitions for a set of types that you use in C. So I give that on this slide. Now, a couple of rules. One rule 1.1, which is required, is that all the code shall conform to the ISO standard 9899/1990, which is really programming language, the standard C programming language ISO standards, including all the amendments and corrections to that standard. Okay. Another example of a rule 13-.3 is that floating point expressions shall not be tested for equality or inequality. If you say this floating point is equal to 0, that's kind of really tough, because the floating point definition doesn't have an infinite fine resolution. Yeah. An example would be if you implement this example. I'm actually adding 0.0001 to x 1,000 times. Well, you would say that's 1,000 times 1,000th, so that would be 1. So, but what you actually see is that's not the case. That's actually this is something is up here. X. Yeah, so but then instead of 1,000, it's going to be 1,000.000061, and that's just because of the floating points. Yeah. So you can of course use a macro to deal with this, or and what you see the macro, what you're doing is you're not looking at 1,000, but you're looking at 1,000 plus or minus 1,000th here. So a couple of other ones, the validity of values passed to a library function shall be checked. This is kind of robustness. If you have a square root function, of course you want to check out if you want to, before you perform square root of x, you want to make sure that x is not smaller than 0. So you need to come up with some range check there. Yeah. Again, here for C, they actually have a required rule if you follow this coding standard that you cannot use dynamic heap memory. So dynamic memory allocation. So this means you cannot use calloc, malloc, realloc, and free. Again, we saw this before too. The function shall have a single point of exit at the end of the function. So this is, and then of course a variety of advisory items.